Hello everyone, today I want to explain my homework 2.c EEG signal processing. This presentation will cover the homework objectives and introduction to EEG, the hardware setup, data loading, and visualization proposition steps including filter and ICA for artifact removal, PSD analyze, and finally the results and conclusion. The main objective of this homework is to process EEG signals to interfere specific brain activities or states. The tasks include loading and visualizing raw data, processing with flattening and remapping, removing artifacts using ICA, analyzing the PSD to classify brain states and comparing the results between healthy and depressive subjective. EEG is a non-invasive method to record the brain's electrical activity using electrode placed on the scalp. It measures voltage fluctuations results from unique clouds in neurons. These signals are categorized into different frequency bands, such as delta, third, alpha, beta, and gamma, each associated with different brain states. The hardware setup involves an EEG cap with electrode placed according to the International 10-20 system, which answers standardized recording. The electrical signals are amplified and recorded in a digital format, such as ADF, for further processing. The first step is to load the EEG data from EDF files using the MNE library's read raw EDF function. Visualizing the raw signals with raw plot helps to inspect the data quality and identify any obvious artifacts, such as the large speck from eye blink. Processing begins with bandpass filter. We pass a filter from 0.5 to 40 Hz to remove DC drift and high-frequency noise, which helps to enhance the signal to noisy retail and focus on the relevant EEG frequency. Next, we resample the data to a standard sampling rate. In this case, 256 Hz. This step ensures consistency across different datasets and makes subsequent processing more complete effect while preserving the essential characters of the EEG signal. Independent computers analyze, or ICA, is a powerful tool for artifact removal. It decompose the EEG signals into independent components, allowing us to identify and remove components that correspond to artifacts like eyes, bleed, or muscle noise. The cleaned signal is then reconstructed by excluding these artifact components. PSD analysis is used to examine the frequency contact of the EEG signal. By applying Wheel's method, we can estimate the power distribution across different frequency bands. This allows us to classify brain states such as relaxed or focused based on the relative power in alpha, beta, and delta bands. Based on the PSD analysis, we can classify brain states. For example, a high alpha power typically indicates a relaxed state while high beta power states out or focused on state. By comparing the band power distribution between healthy and depressive subjects as shown in the chart on the right, we can observe significant difference. Specifically, we often see higher delta and power and lower alpha and beta power in depressive subjectives, which helps us differentiate their brain activity patterns. In summary, I successfully loaded, visualized, and processed the EEG data. I applied ICA to effectively remove artifacts and conducts PSD analysis to compare brain activity pattern between healthy and depressive subjects, identifying distinct brain state based on the frequency band power distribution. This homework provides valuable hands-on experience with EEG signal processing. Key technical like Flanter, ICA, and PSD analysis are fundamental for understanding brain activity. The ability to classify brain state from EEG data has significant application in both nurse research and clinical diagnosis. Let's look at this video. This is my Python code. This is just word error, not about code. Code is right. Just because word. This is all my homework to Part C. Thanks for listening. See you.